This video is going to explore a few problems from section 3.5 of the book. Specifically on page 153, I'm going to look at numbers 12, 17, 24, and 55. If you want to try these beforehand and check your answers, you can do that now. You can just pause the video and go and work out the problems and then come back later and just check how your answers compare with the ones that I do. Okay, number 12. Basically just finding derivatives of functions. This one is x squared cosine x. You can see in this case that we have the function is a product of two functions of x, because this last thing you do is the multiply right here. So we have an x squared and a cosine x multiplied together, so the derivative must be the product rule. You take the first x squared times the derivative of cosine, which is negative sine, plus, now you take the derivative of x squared, which is 2x, multiply that by the second function, which is cosine. And that's it. Number 17. You are looking for a function r of theta equals e to the sine 3 theta. The last operation that we do is this exponential here. So we're going to have to use the exponential rule. So the derivative is, you're taking the derivative of e. Well, derivative of e to any power is e to that power. So I write down e to the sine 3x, multiplied now by the derivative of the exponent. So I take the derivative of sine 3x. So I take the derivative of sine, that gives me cosine of 3 theta. Now you multiply by the derivative of 3 theta, which is 3. And we can leave it like that. Number 24. You have the function k of x equals square root of parentheses sine of 2x cubed. Now the cube is underneath the square root sign. So the easiest way to write this is use a power. We're taking this function in here, sine of 2x, cubing it, and then taking the square root. That's equivalent to saying this is sine of 2x, all raised to the 3/2 power. These two expressions are equivalent. Now notice I haven't taken a derivative, so I can't stop. Now I can start and take a derivative. K prime of x is equal to, use power rule, 3/2 times sine of 2x. Subtract 1 from the power gives you a half. Multiply now by the derivative of sine 2x. That is cosine 2x. Now we multiply by the derivative of 2x, which is 2. And that's good enough. Finally, number 55. This says let, this looks like fun, f prime of x equal to sine of x squared. And you're supposed to find h double prime of x if h of x is f of x squared. So, first I'm going to find h prime. I'm going to differentiate this function here. Notice as a composition, I'm composing the function x squared with the function f. So really the last thing I do is I'm doing f, so I need to differentiate that first. This is f prime at x squared, multiplied now by the derivative of x squared, which is 2x. Now, I'm going to substitute for this expression here, f prime of x squared. Notice above it tells me what f prime of x is. F prime of x is sine x squared. Therefore, to find f prime of x squared, every time I see an x, I put an x squared. Every time I see an x, I put an x squared. So this is sine of x squared times 2x. Or, the same thing as saying 2x sine of x to the fourth. Because when you take square to a square, here you combine the exponents by multiplying. So this expression is actually h prime. Now I find h double prime by just taking the derivative of this using power rule. It is first 2x times the derivative of the second. The derivative of sine x to the fourth is cosine x to the fourth times the derivative of x to the fourth, which is 4x cubed. Then I add to it the derivative of the first function, derivative of 2x is 2, multiplied by the second function, sine of x to the fourth. And there is your answer. I guess you could, if you wanted to, factor out a 2x. You have a 2x, oops, never mind, sorry. You have the 2 you can pull out. The 2 here and a 2 there, but I just leave it like that, and I think that's fine.